Hi, my name is Warren Kelm. I'm a FARO Technologies employee, and today we're going to be talking about suspect height analysis. So once you've opened up Scene software, you're going to find where your scan is located. Go ahead and drag that over into your project workspace. Exit out of that, go and find the images folder. So there's a series of photos that were taken here. What we're looking for are photos that not only combine our suspect in the most upright position possible, but where there's also surrounding information within the screenshot that we can identify as specific points in 3D space. So in some of these photos, you see that he's standing relatively upright, but there's not a whole lot of identifiable objects in space. We'll be going into more detail as to what I mean there here in just a moment. So as we've gone through and we're looking at the selection of photos that we have, you see this one where he is reaching out. Again, we're going back and through just to make sure, but this one where he's reaching out looks like we have him in a pretty upright stance. You also see that there's a lot of different things that are within view that we can possibly use to be able to tie this together. So I find that which was 444 and go ahead and just drag that over into my workspace as well. And then I can close down the folder. It's going to ask me to go ahead and apply that as a virtual. I go ahead and just click OK. It comes up as the default setting. Then I'm going to go into my scan, open that up into a planar view. Once the planar view is opened, I want to identify the area where my suspect was standing inside of my closed circuit TV image shot or whatever photograph you may have that you're trying to apply to this particular 3D environment. So as soon as this has opened up, you'll see where we're going to use the polygon tool. So I'm going to identify the area on the floor here where the subject was seen standing in the photo. Use my polygon tool and I identify that same general area on the floor. It doesn't have to be this big. I'm just selecting a relatively large area. And then I'm going to go to create object, and I see that once I've created the object as a plane, I see that I've got all green lights and everything looks good as far as tolerances. I can go ahead and identify that I've got a green plane symbol there indicating that we did have good points to identify the plane, and go ahead and hit Control D to deselect. From there I'm going to select my photograph, go to Operations, Registration, and Place in 3D. So what I want to do here is I want to select the plane I just identified and use that as my selection point. When I put Set, what it's going to do is it's going to open up the photo that I just brought in so that I can start selecting where that set point, in this case the base of the foot, where that needs to be. So what I'm going to do is I'm going to zoom in. What I'm looking for is something that's relatively medial or in the center of where the bones straight up and down the leg would go, so that I'm getting as correct a height as possible. From there, I've already selected my plane, I selected set. It's going to come up with this error box. Don't worry about that. Go ahead and hit view and then associate points. What this is going to do is it's going to give us the ability to go back and forth between the scan and our photo in order to be able to identify those particular points in 3D space that are common between the photo and the scan. This is commonly known as photogrammetry. The difference being is that we're not comparing two photographs that are taken in 2D and trying to create a 3D planar environment or 3D volumetric environment. What we're doing is actually converting our 3D true measured environment utilizing the 2D image to be able to create a very accurate measurement. So now you notice here while I was trying to move around, and you have to use your pan and zoom using the control key on your keyboard to be able to move around. Just using your mouse wheel allows you to zoom out, and then when you identify the area you want to mark, just zoom in on that using your mark that you see on the screen along with your mouse wheel, and it'll just zoom on that area. Be very careful and really zoom in on these, because the further off you are, the greater your rate of error is going to be. So as you see, I've selected two that are basically in line with each other at a relatively high position in the room. I'm going to find a couple of spots that are mid position within the room. And again, you want to be pretty careful to make sure that you're selecting points that are very commonly, easily identified. You'll notice that there are certain things that are within the view of the scan and within the view of this photo that I can click on and be very confident that I'm clicking on points that are the same in both. Your ideal is to try and pick at least 8 corresponding points. Obviously, the more points that you pick, the better your subsection is going to be, and as a result of that, your overall fit between your scan, your picture, and your end resultant are going to be much better. Now you see I can move this around. When I do that, I have to go back in and reselect this in order to allow me to zoom in and zoom out. So just be cognizant of what you're working on, whether it's the associate box or the actual scan or photo. So I'm continuing to go through and pick these common points that I can see in both, and you can see I'm starting to get a fairly wide selection of different points in space that are spread out throughout basically the width of the entire photo. What this is doing is it's giving me a very spread out target base in which allows the software to be able to figure out exactly how this photo fits within 3D space, because a lot of our closed circuit TV images, of course, are located in a relatively high position, looking down on something, so we're getting a bit of an oblique angle, and we're having to take that into account. Now, the one thing that you're going to see is that I'm going to use the corner of the table here. This is not something I would typically recommend, simply because the table could move, and if you did that, there's a possibility that this would not work out well for you. In this particular case, I'm pretty confident the table had not moved from the time the scan was done to the time that these photos were taken, so I went ahead and used it. But you want to be careful not to use things that are going to move. In this case, you see I've got a green light, a very small resection amount. Everything looks like it's good to go. When I close down my picture view, you see where the planar view fit, and that's relative in position to what I was seeing as far as the photograph and the overlay. Once I close this down, I can then go into my photograph again in the planar view with the photograph. And once I open up the planar view, I just select the measurement tool. So I'm going to go up here to the bar, select measurement tool. Again, I'm going to pick that point that's most straight line of the bones in the leg. And I'm going to go ahead and go to the top of his head. Remember that we can account for offsets as far as horizontal, as you can see there. So our overall vertical distance here is 66, so we've got 5 feet 6 inches in height, and I believe we're within about a ½ inch of the subject's height in this particular case. So that's how easy it is to be able to do this. The FARO will allow you to get within 1 inch of your suspect's height. Thank you and have a great day.